Today, on how it's made. Steel shipping drums. They have the competition over a barrel. Police whistles. A device that's a real traffic stopper. Miniature train cars. Historic designs with a great track record. And glass blocks. This report's perfectly clear. The steel shipping drum was invented in the late 19th century for the oil industry, which needed an alternative to leaky wooden barrels. But those first steel drums also leaked from their soldered seams. Welding them proved to be the solution, giving this container an airtight reputation. It's a product that really delivers the goods. To make steel shipping drums, a punch press cuts and forms the bottoms in one swoop. A conveyor shuttles the bottoms down the line to a turntable. As it rotates on the turntable, a nozzle sprays sealant onto it, coating it completely. They stack up the drum bottoms. Meanwhile, another punch press shapes steel discs into tops for the drums. Rollers turn up the outer edge to a precise measurement. Next, steel fittings tumble down a vibratory conveyor to a machine that simultaneously punches threaded openings in the tops and inserts the fittings. One hole is for opening and closing the drum, while the other is to vent. At this station, they check the thickness of sheet steel that will be used for the body of the drum. The thickness varies depending on what the container is to hold. A machine called a shear slices the coiled steel into sheets. The steel sheets then move on to a forming machine, where rollers curl them into a tubular shape that is the drum's shell. Automated pushers then move each shell through an electric resistance welder. It generates heat to weld the side seam, bonding it from both the inside and the outside so it won't leak. The shells roll down to a machine called a flanger. The flanger stretches and presses on the outer rims at both ends, creating a lip. Then it's over to a machine called a beater. Its rollers bear down on the shells to make grooves called rolling hoops. These rolling hoops add rigidity to the shells. The shells now travel down another conveyor and merge with the drum tops. Automated pushers deliver a top to the base of a shell. The shell rotates in a spinning clamp as rollers curl the edges of top and shell together. This creates an interlocked seam called a chime. Another roller then flattens the chime. Mechanized arms flip the shells so the bottoms can now be installed. To join the bottoms to the shells, rollers form another chime. These interlocking seams are comprised of 7 layers of steel, making them leak-proof. That's critical, since the steel drums may be used to transport hazardous goods. The steel drums now move forward to a testing station. Here, they inject air into each drum and check the seams for leaks. The seams have been soaped up, so if bubbles materialize, it signifies a problem. The steel drums then go for a whirl under the paint gun. It sprays them with enamel paint as they rotate, giving them a protective sheen. Black is the most common color for these shipping containers, but custom colors are sometimes ordered. The steel drums then journey through an oven to bake the paint to a hard finish. They then gauge the thickness of the paint with a special tool to confirm that it's thick enough to withstand rusting. They plug both openings and put a temporary seal on the vent to prevent tampering. After that, these steel shipping drums are ready for the long haul. It was in the late 19th century that London police started using a special whistle to get attention. It was lightweight and had a piercing sound, and was a real improvement on the hand rattles they'd been using. That same design is still used today. It's why a police whistle is a real blast from the past.
Stop!
Blowing the whistle on lawbreakers and traffic offenders is an ear-splitting ritual. The average traffic officer blows on one thousands of times a day, so the whistles have to resist a lot of spit. The whistle's body is made of high-grade brass tubing in which they punch 2 slots. These are sound holes that will allow the noise to escape. Using hydraulic pressure, they stamp the brand name onto the tube. Next, they make the mouthpiece. Rollers sculpt a piece of spinning brass into a shape that's a bit like an hourglass. With the mouthpiece complete, they use a hydraulic punch to bend a piece of brass into a part called the slab. The slab will be used to create 2 sound chambers inside the whistle. They fit a loop onto an end cap. The loop will make the whistle easier to hang on to. A rotating press bends the loop's tab against the inside of the cap to fasten them together permanently. They attach an end cap to the slab, and then force the slab into the cavity of the whistle, splitting it into 2 chambers. A police whistle actually produces 2 notes at once, giving it that distinctive timbre. These 2 separate sound chambers will produce 2 different pitches. They now dip the ends of the whistle in solder paste, and then hammer the looped cap and mouthpiece onto the pasted ends. The solder paste is a special lead-free compound, so the whistleblower won't be exposed to toxins. They also insert solder wires in the whistle chambers before capping the ends. These solder wires will act in conjunction with the solder paste to seal the whistle in a process that happens next. The whistles move through an electromagnetic induction coil, which heats them to a smoking 220 degrees Celsius. This causes the solder paste and wires inside to melt and flow into the whistle's seams. They then quench each whistle in an acid bath, which hardens the solder, sealing the whistle's seams. Next, they lower the whistles into a nickel bath, where positively charged nickel ions migrate to the negatively charged whistles. Now, it's time to make noise. They test each whistle with compressed air. The tiniest pinhole will cause a whistle to fail, and that happens in 3% of them. Failure is a crushing experience. They flatten the rejects and send them to a company that will reclaim the metal. On both land and sea, whistles are the sound of authority. Here, they assemble a bosun's pipe used by naval officers to issue commands and salute dignitaries. There's a tiny hole in the ball at the end of this pipe. The player opens and closes that hole with his hand to change the whistle's pitch. And with that, production comes to a screeching stop at the whistle factory. Making miniature train cars is all about the details. Every feature is scaled down to a fraction of the size of the real thing, and nothing is too small to replicate. Because each train car is just like the real McCoy, it's more than just a toy, it's a collectible. On a miniature train track, the past comes full circle with replicas of trains from days gone by. They start with historical photos and drawings of actual train cars and scale them down to 1/48th size. They feed polystyrene pellets like these to an injection molding machine. It melts the pellets into a thick paste. The 4 sections of a mold close and nozzles pump the plastic into it. It oozes into all the grooves and hardens almost instantly into the shape of a train car. Then they clip off excess plastic. Here's a view of how the 4 parts of the mold come together to shape melted plastic into a boxcar. They even make holes in the boxcar to attach accessories. And they impress details like ridging that mimic the steel ribs of the original life-size train car. Using other molds, they replicate door rails, brake wheels, and other accessories. The assembler clips the parts off the framework and files down the rough sections. That's the brake wheel she's snapping onto the end of the model. Using a hobby knife, she trims excess plastic from the train car's step. She then glues a steel weight to the bottom of the train car to make it 1/48th the weight of the real thing. Making something to scale is a bit of a balancing act. Finally, she attaches air brake tanks to the underframe of the car. And it's time to spray paint the model train car, vivid orange. It's a color that would have been used on an actual boxcar, combined with white. For that two-toned look, they hold the model in a paint shield to protect the sections that are to remain orange as they spray the sides white. This technique ensures the paint job has clean lines. They leave the car to dry overnight. Other train cars receive a less flashy paint job. This car is basic black, and it's the perfect canvas for white lettering. A pad picks up the ink from letter engravings on a printing plate and transfers the image to the car. Metal wheels now roll off a revolving conveyor. They funnel into mechanisms that press fit them onto each end of metal axles. The wheel and axle assemblies drop into a bin below. 2 sets of wheels are now installed on a plastic framework. They attach the framework to a coupler, the device that links train cars. They screw the 4 wheels and coupler assembly onto one end of the car, and they install another one on the other end. They snap the couplers together to connect 2 train cars. In the world of train models, a little grime is just fine. They make it look dusty on purpose by misting the model with paint. The painter layers colors to get just the right effect. This technique adds an element of realism to the model train car. It's all a matter of preference. Some hobbyists prefer this weathered look, while others like their model trains shiny and new. The model train cars have now rolled off the assembly line, and they're ready to roll down a mini rail line. It'll be a whistle-stop tour to another era. When it comes to building materials, glass blocks are clearly a classic. In the 1920s and 30s, they were a cornerstone of the Art Deco style of architecture. Today, glass blocks are still popular for creating walls, windows, and stunning design features, a stylish way to erect a privacy barrier that lets in light. Glass blocks aren't just decorative. They insulate from heat, cold, and noise. They begin with just 4 ingredients: recycled glass pieces called cullet, sand, soda ash, and limestone. A computerized system portions out each one and feeds them into a melter. This giant furnace heats the batch of ingredients to a fiery 1500 degrees Celsius, transforming them into molten glass. The melter pumps out enough molten glass to make 1/2 block at a time. Automated shears slice it off. The gob of glass then slides into a waiting mold. A plunger pushes the gob down, spreading glass throughout the mold cavity. Its waffled surface imprints that pattern into the glass. Pipes overhead blast ambient air that cools down the molten glass drastically, from 1000 to 600 degrees Celsius, in just a few seconds. This way, they don't lose their shape when this retractable arm extracts them from the mold and lays them on a conveyor belt leading into a sealing machine. This is where 2 half blocks join together to form a full block. Entering the machine, each piece passes over a series of burners that keep the glass temperature constant. Sudden cooling could crack or shatter the glass. The machine then slowly reheats the half blocks until their edges start melting. They enter the part of the machine called the squeeze station. There, an automated press forces a top half and bottom half together. Their melted edges fuse, forming a single block. The blocks now travel into a layer, an oven that cools the glass at regulated temperatures over several hours. This annealing process prevents cracking and allows the glass time to set properly. The glass temperature going in is about 1000 degrees Celsius. Coming out, it's down to 80 degrees or so. The blocks are now ready for inspection. Workers use digital alignment gauges to make sure both halves are flush. Then they run a straight piece of steel along the block's surface to check for any distortion. Each and every block must meet precise standards for both size and shape. This finished block is a 19 centimeter square that's 10 centimeters thick. Building with glass blocks is similar to building with bricks. You use mortar to stick them together. To prep the blocks for mortaring, workers now place each one onto a separate station. As it spins, nozzles spray the edges with liquid vinyl. This coating will help the mortar stick to the glass surface. Just one last step. An inkjet printer applies the product code along with the manufacturing date and time. The quality control department runs samples through an impact test. A worker drops a weight through a tube onto the side of the block. This verifies the strength of the sidewall and the seal between the two halves. Finally, the glass blocks are ready for shipping. Workers pack them into cardboard boxes that have block-sized sections to keep them safe during transport. Glass blocks come in so many shapes, sizes, and patterns that the design possibilities are endless, both practical and beautiful. It's no wonder they're so popular with builders and decorators alike.